Hey y'all, it's me, Miss B. Today we are graphing sine and cosine equations. First we have to graph the parent functions, and then we're going to transform those functions as well. Just a reminder that we did see this in chapter 1.6, day 1 and 2, if you need a reminder. Okay, I just picked any old graph y equals cosine of x. And so then we have our um, our x and y, and then we're going to fill in this table. These tables are going to be really important. And I do want to remind you that we have x is cosine of theta and y is sine of theta. So I'm going to go ahead and fill in this unit circle. So at these endpoints here, this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so the distance is 1 and everything in between here. So this is like, um, this is pi over 4, and it's radical 2 over 2, radical 2 over 2. So remember that our points are only going between, I'm sorry, not for domain, for our range. Our points are only going between -1 and 1. And so those points are going to lie at these points on the axes. So those are going to be our key points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi are going to be our key points because they are our high points and our low points. You can graph more points if you really want to, but they're less useful and more work. Okay, so let's go ahead and label these points. This is the point 1, 0, if this is a unit circle. 0, 1, -1, 0, and 0, -1. Okay, remember that cosine is our x value, so I'm going to just go ahead and highlight these x values because they're going to be our, if we find cosine of x, then y is going to be 1. So this is cosine at 0 is 1. Cosine at pi over 2 is 0. Cosine at pi is -1. Cosine at 3 pi over 2 is 0. And cosine back at 2 pi is 1. Okay, so here, just a reminder of those, what each of those values do. I'm not going to go through them since we've already had notes over them, but feel free to pause and copy them down if you would like. Okay, so to find our x values, so if we're transforming, what we're going to do is we're going to subtract c and divide b to our original, from parent x values. And then for our y values, we'd multiply a and add d from our parent y. Okay, remember that changes in x are inside the parentheses and changes in y are outside those parentheses. So let's go ahead and get an idea of what these parent functions are going to look like. So sine, we've got x and y. Again, we're going to start with the same values. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Always starting with those same values. For sine, we start at 0, 1, 0, -1, 0. And I'm getting these values just from our unit circle. It's the unhighlighted y values. So these are from the unit circle. Okay, So then we're going to plot these points, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So we graph. It's going to have a bit of a curve to it, and that's okay. All right, and it's just going to keep going up and down like that forever. So let's talk about 5 pi over 4. So 5 pi over 4, let's look at our unit circle first. So 5 pi over 4, so that is 1, 2, 3, 4. 5 pi over 4 is right here. And so this is the point, negative radical 2 over 2, negative radical 2 over 2. So the square root of 2 over 2 is about 0.7, I believe. And if you zoom in, this is about negative 0.7, which is negative radical 2 over 2. So you can see that that 5 pi over 4 is equal to that negative radical 2 over 2. We don't have to plot those points, but it is helpful to know that that is where those in-between points are coming from. So if we just plot our parent values, we don't have to do all the other stuff in between. All right, and then cosine, we already have that table from our first page. So we have x and y, 0, pi over 2, pi, 3 pi over 2, and 2 pi. This point is 1, 0, negative 1, 0, 1. You will start to pick up on those patterns if you haven't already. And so then we'll plot 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi 1. And again, it has a bit of a curve to it, like so. Okay, so I want you to go ahead and note any differences or observations you have about sine and cosine here. Okay, let's go ahead and define amplitude and period. So amplitude is half the distance between the crest and the trough, so our high point and our low point. In this case, our crest is 1 and our trough is negative 1, so half that distance is 1. So our parent functions do have an amplitude of 1. Okay, we're going to come back to the definition for period in just a moment. Let's jump into some examples with amplitude first. Okay, so here I'm going to just write out my x and y values. So we have sine, so I'm just going to start with our parent function. It's going to be the exact same as here. I'm actually just going to copy and paste this so I don't have to write it all down again. Let me actually delete these old ones here. Okay, so I have x and y, and it's 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So this is our parent function, and we want to transform it to have an amplitude of 2. Okay, so this is going to cause a change in y because it's outside those parentheses. So our x values are actually going to stay the same. And our y values, what we're going to do is we're going to multiply each of these by 2. So end up with 0, 2, 0, negative 2, 0. So then let's go ahead and plot our new graph, which is this one here. Okay, so we have 0, 0, pi over 2, 2, pi 0, 3 pi over 2, negative 2, and 2 pi 0. So when we graph this, remember to have a bit of a curve. And so as you can see, it's the same graph, just slightly taller. Okay, now let's talk about the period. So the period is the distance required for the function to complete one cycle. So if you think about it, if I have, I'm going to zoom in here to have some space. If I have a circle, and then I have a bigger circle, which circle are you going to travel around faster, the small one or the large one? You should say that you're going to travel around the small one faster, okay? So, basically what the period is saying is that the our radius of our circle has gotten smaller, so then the cycle is going to complete faster or slower depending on that value. So this right here, what this is saying is that our period is moving twice as fast. Or 2 times as fast. Let's use 2 times. So if our period is moving 2 times as fast, and we normally get through a period in 2 pi, how long would it take us to get through a period that's moving twice as fast? So if our period is moving twice as fast, we can set this up as an equation. So if I have 2x is equal to my 2 pi, and I divide by 2, then my period is now getting done in pi. Okay, but let's look at this algebraically rather than just trusting Miss B. So here I've got my x and my y. These are my parent, and this is cosine. So we want to make sure we copy our cosine graph. So 0, pi over 2, 3 pi over 2. Wait, no, that's not right. Pi over 2, pi, 3 pi over 2, and 2 pi. And then our y values are 1, 0, negative 1, 0, 1. Okay, so then for a transformed graph, x is going to stay, I'm sorry, y is going to stay the same because there's no change in y, just a change in x because it's inside the parentheses. So these are going to stay the same. But then for x, what we're going to do is we're going to multiply, I'm sorry, if you remember from our notes, we are going to divide by our b value. So we don't have a c value, but we're going to divide by our b value. So we're going to take each of these values and divide them by 2. I'm going to rewrite these so we have room to show our math in here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if you remember, dividing by 2 is the same thing as multiplying by a half. So I'm going to multiply each of these by a half, just so when we're working with fractions, it makes a little bit more sense. So multiplying by 2 same as dividing by a half. So I divide each of these values by 2, and I get 0, pi over 4, pi over 2, 3 pi over 4, and 4 pi, pi. And we want to plot these values. So 0, 1, pi over 4, 0, pi over 2, negative 1, 3 pi over 4, 0, and pi 1. So I'm actually going to keep going with the pattern here just to keep showing. So it keeps going up and down. So if we keep going with our pattern, you know what? Actually, let's not keep going with the pattern. Let's stop here just to show that point. So if you look, this graph and this graph have the same amplitude, but they're getting done in half the amount of time. Now, like I said, if we were to continue, you'll notice that, let me use the dotted thing. If you keep going, you'll notice that we got through 2 whole periods in in 2 pi. So that's what it's saying. In 2 pi, amount of time, we get through 2 periods. So that's actually what this 2 means. Okay, so because it's moving twice as fast, we can get twice as much done in the same amount of time. Okay, let's do this last example here where we have a change in both. So we've got sine. I'm gonna go ahead and write our parent function first. Actually, I'm gonna copy and paste it just like I did before. Prove my point that it's the exact same. Okay, and then we want to, I'm gonna move these over a little bit. Okay, and then we want to transform each of these functions. So let's talk about what each of these values is doing. This 3 is a change in y. It's changing the amplitude. So we're going to take each of these y values and multiply by 3. This value here is a change in x. We're going to take each of these x values and divide by a half. Remember that dividing by a half is the same as multiplying by 2. So I'm going to take each of these values and multiply them by 2. And I'm taking each of these values and multiplying them by 3. So here for x we get 0, pi, 2 pi, 3 pi, 4 pi. So it's going half as fast, so it's going to take us longer to get through one whole period. And then for y, we get 0, 3, 0, negative 3, 0. So that's changing the height. Let's go ahead and plot these points. So my function, it's 0, 0. Oh my goodness. 0, 0, pi, 3, 2 pi, 0, And I run out of room, so I'm actually going to continue the pattern this opposite direction just so we can get a full picture. So hopefully I can give you graphs that actually are big enough next time. All right, so that is what our graph looks like, and it does keep going. And it starts here at 0, 0. If you look, it takes 4 pi to get through one whole period, and it's 3 times as tall. Okay, so you're changing the x and y values for each of those based on whether the change is on the outside or the inside. That's all for today, folks.